All right, good morning. How are you guys doing? I do have a silly poll up. We're going to finish chapter 6. We're just on the very last bit, the PiratePizza Ad. All right, let me end the poll and show it to you. Very lawyerly result, I guess, is the winner is, it depends how you define pajamas. So that's fine. All right, so you should see this chapter 6 slide on screen, and this is where we left off last time, the PiratePizza Ad. Our chapter 6 coverage has been on calculations, and we've kind of covered a lot of ground on how to get Java or any strictly typed language to misbehave, to get results that are maybe unexpected or certainly could be considered incorrect or are presented poorly. So all sorts of ways things can go astray. The PiratePizza Ad is our first attempt this semester to do some calculations really involving money amounts, and to present the results. And you can see in the screenshot of the PiratePizza Ad, I'll run it in just a second, but I've picked numbers that where the app prompts you for the price of the daily pizza special and the price of the daily veggie special. And then it adds taxes and it generates this little graphic that could be saved as a ping or a JPEG and uploaded to a web server to appear on the company's website or whatever. I mean, it's just really an attempt to do some calculations, and you can see the results that I've got displayed there are quite poor. The pepperoni special is $5.2 and the veggie special is $7.0. They're not the kind of numbers you would want to present to a customer, certainly. Let me run it. It's part of the download for chapter 6, and I actually have two versions of it. If you've peeked in the download, there's PiratePizza Ad and there's PiratePizza Ad 2. They do the exact same calculation. The PiratePizza Ad 2 was just designed to allow itself to be resized, but I'm not going to run that one. But if you want to, don't shy away. That's the difference. If you want to peek, whoa, I'm sorry. So you should see a lot of code. This is the PiratePizza Ad. So let me run it just so that what I do in here is a little bit more clear. It's a fairly small app. If you press the button, it prompts you for what is the price of the pepperoni special. So we can say whatever. Let's say it's $5.50. Price of the veggie special is, I don't know, $6.25. And then, well, so I really lucked out. I got two numbers that were bad. So the app just adds a tax rate to them that's fixed in the program, is hard-coded in, and then rounds the results to 2 decimal places and then displays the results. So you can see at the console, you can see that the actual numbers, the result of adding the tax for the pepperoni special is 5.89875, and for the veggie special it's 6.703125. So those are clearly not numbers that you would want to present to the user. They need to be rounded, and they need to be rounded to 2 decimal places, which is the amount we round. Most currencies, it's not super tough to do, but you'll see somehow it's been bungled in the results. So the pepperoni special is displayed as $5.9 and the veggie special is $6.7. And so the veggie special is, well, they're both actually pretty easy. You can see 5.89875 would be rounded up to 5.90, and 6.703125 would be rounded down to 6.70. The problem is those are double precision numbers, and Java only retains the first 0 after the decimal place. So if something does round to, for instance, 5.90, the 0 will not be stored. Same thing with 6.70, the 0 will not be stored. So that's why you're seeing the result here in the PiratePizza Ad kind of poorly. Let's look at the code though, and I'm going to switch back to the presentation. Here's the code that prompts the users for the 2 amounts. So I just use the input dialogues. We used that early in the semester. So it puts up that dialog that says, what is the price of the pepperoni special today? And whatever the user types in, it stores in a variable I've called pepperoni special price $. And then I've got to convert it into a number to do math on it. I want to do math on it so that I can add the tax. I can't add tax to a string or to a text value because you can't do math on text. So I have to do this conversion. I use the parse double method that's built into the double class, the double wrapper class that we've talked a little bit about. And I also trim the special, I trim whatever the user entered, pepperoni special price string.trim. And again, that's just in case the user typed 6.5 and then hit a space, before hitting return. If I try to parse that, the parse method is very sensitive to the string data that you feed it. And if there is a leading or a trailing space, it will cause the parse methods to fail. So trimming there is always a great idea, or at some point before you try to do something with text in terms of converting it to a number. And then I just add the tags. So you can see the line of code there. The calculation here is pepperoni special equals add.pepperoni special times tax rate plus 1. So again, the tax rate's hard-coded in. Those long decimal values are the result of this math and are stored in pepperoni special and veggie special. And then I try to round and format the result for presentation as money. And this is what I generally call something along the lines of the bad money round technique. It is probably the first way everybody tries to round money. It's not good from at least 2 standpoints, but let's just see what it is first. There is a round method in Java. It's stored in the math library. It's called round. It's very simple. It rounds to the nearest whole number. It keeps no decimal places. And that cannot be configured. That's just what Math.round does. So to get it to round to 2 decimal places, what you would do is multiply your number by 100, do the round, and then divide by 100 to get your decimal places back. And that will work fine, again with some clear caveats. And then I just use string concatenation to append the $sign onto the front of that. So the whole line of code there is pepperoni special price string, that is what I want to display now, starts with a $sign and then has a rounded version of the result of the calculation to 2 decimal places. If that worked perfectly, then you would expect to see nice results, but we don't. So there's 2 problems with that I mentioned. I think I mentioned last time, but let me just say it again. Obviously, the trailing 0 is not kept, so presentation of amounts that end in a 0 is not going to work well using this technique. And then also the rounding approach itself, Math.round uses half up, so it rounds up at 0.5, which is also not what we want. That's not the way you're supposed to round money. You're supposed to use half even or bankers rounding, which we'll get to in chapter 15. But this is certainly a perfectly good way to start out with money, if only for the sake of showing you that it's not, although it's a very common approach used, it's not a good approach. And it's one of these things, hopefully it bugs you a little bit that the zeros aren't there, and also that we're not rounding it correctly. The last bit of complexity in this app, which I don't think is complexity anymore to you guys, is the ad itself is drawn using a custom JPanel. So I've got the code here just so that you can peek at it. I call it AdPanel, and you can see I've provided the AdPanel with some attributes. So I've stored stuff like the restaurant name, the tax rate, the variables for the pepperoni and veggie special set to 0, initialized to 0, and the 2 strings, the pepperoni special price string and the veggie special price string. Again, using a $sign there is not required. It's not even necessarily following Java's guidelines. I mean, I picked it up from other languages, but for me it's helpful to have 2 versions of the variable, and one of them that's the string version, I put the $sign on, and the other that's the double version, I leave it off. In any event, you can see in Paint Components, I'm doing the stuff that we generally do. I have rolled in variables for the size of the J-frame here. And so all you're seeing is a little bit of additional math that looks at how big the J-frame is and then scales the rectangle and the fonts based on the width of the ad as it's displayed, which allows you to, if you wanted to, I guess, display a larger version of the ad and not have to recode the app. So it's a little bit overkill, but it's part of that, leads into that next version, which allows you to do this live and resize it live. But that's calculations. This chapter 6 is a big chapter. It's a chapter that does throw people sometimes. We talked about this a little bit last time, and there was a poll, and that, half of you are more didn't really know that computers could be made to trip up quite so badly, and we're not aware of difficulties, doing certain types of math in these strictly data typed general purpose languages. Hopefully you also come out with an appreciation of the different data types and the cautions associated with doing math in these data types, and even more generally just mixing the data types in a calculation and what can happen and what you need to do to make certain calculations work. For almost everybody who hits this chapter, myself included, I mean, not this chapter, I wrote this chapter, but in the book I was reading, I struggled with this because none of the languages I had previously learned were strictly data typed. So this was a surprise. That's the end of chapter 6. So we're going to move on to chapter 8. We are, for the most part, bypassing chapter 7, as I mentioned. We're a little bit behind, but that's fine. I'm going to cover it at the pace that I think we can cover it at, and I'll pull stuff out of chapter 7 where it makes sense to, and integrate it into these lessons so that you do get some of the complexity of chapter 7. We are skipping ahead to chapter 8, which is logic and program flow. And I'll start right off by saying, if you've looked at the keynote that you can access on the course app, you'll notice it's a big keynote. I think it's over 40 slides. We'll need more time, so as not to rush through it unduly. It is an important chapter, understanding flow of control, understanding how to write your code and where to put the statements and how to order the statements to get the behavior, the functionality that you want is a crucial programming skill. We've already talked about flow of control several times. You know that, for instance, the basic flow of control is that the instance variables are read in and are initialized first in your code if you've listed any. You know that the main method in your app runs first. If you call methods in your main method, the flow of control will jump from the main method to those called methods, including the constructor, and then back to the main method to finish it out. Today we go kind of the next step, which is, well, what about inside of methods? So far inside of methods, everything's gone simply top to bottom. That is often not the way we need to program it, because we need our program to react to user input, or react to the input of a sensor, or react to something that's been read out of a database or from a web service. And we don't know in advance what the value we're going to read in is, but we know that we'll need to respond to the data in some way that makes sense and depends on the values that we're given. I should say also, in terms of event handling, starting in chapter 4, also we've had apps with widgets that were listened to, and the flow of control in our app when it ran jumps to the handler methods that are tied to the widgets that the user touches. So we actually have learned quite a bit about flow of control, but then again, inside of all of these methods, inside the main method, inside the constructor method, inside the event handling methods, the flow of control has been top to bottom, and that is not good enough for complex programs, which is essentially what this slide says. So we do most of this using Boolean logic, Boolean algebra, named after George Boole. I don't know if it's appropriate to say he's the inventor or the discoverer of this sort of logical math, but he's the one who codified it. So in Java, there is a Boolean data type. It can hold either true or false. When writing about Booleans, it does typically get capitalized or frequently get capitalized. And you also know that there's a wrapper class called Boolean with a capital B that's different than the primitive data type. We will, for the most part, use the lowercase b built-in primitive data type to store true-false values. So for the most part, in our code, you'll see Boolean always as a lowercase letter. It can only hold two values, true or false. You guys know that. And Java is super picky about that. It has to be all lowercase. And unlike other languages where it could be a 0 or a 1 or a yes or a no even, Java will not take anything but true and false. We use Boolean values to create Boolean expressions, or these are sometimes called conditional expressions or conditional tests or Boolean tests. The thing to know about these is that the result of a Boolean expression will be a Boolean true or false. They will evaluate to being either true or false depending on the evaluations in the expression that you've written, the comparisons, the logic, and or and not logic that you've thrown in there. However you've written it, when Java plugs in the values, for instance, that the user's entered or that have been read into the program, the result of a conditional test is a true or a false. And then based on that true or false, the code splits, the code branches, so that some code is executed and other code is skipped, or that some code is executed more than one time. So writing these sorts of conditional statements is the fundamental skill that you'll need to master to take control of flow of control. The syntax is similar to other languages that you might have used with a couple of exceptions that we talked about, I think, in chapter 2, or the overview chapter. The Boolean operators are listed here: greater than, less than. Equal to is the double equal sign. So Java distinguishes between a single equal sign, which is the assignment operator, and the double equal sign, which is the Boolean equals evaluation. Not equals, the operator is exclamation point equals, which if you haven't seen that before, it certainly does look kind of odd. You do get used to it, and the key to understanding why it is what it is just to look down at the bottom row, and you'll see that the not operator is the exclamation point. So if you precede a Boolean value or a Boolean condition with the exclamation point, it nots it, which is it flips it, either from true to false or false to true. So exclamation point in Java is not. So jumping back up to the fourth row, then not equals is written exclamation point equals. Less than or equal to and greater than or equal to are shown. And then the and the or, the other oddities that I've mentioned before. Java does not use the words and or. Those are not keywords. It uses the double ampersand and the double vertical pipe symbol to do and or. So again, these may not match up exactly with symbols you've used in other languages, but you do get the hang of it fairly quickly. I know certainly switching between languages, sometimes you start writing using the wrong syntax, but of course Eclipse will, for the most part, point it out to you very quickly and let you know that you've done it wrong. I know some of this is review to the extent that we did talk about this in the introductory overview chapter, but this is where we go into more detail on it. All right, so the most basic way we use Boolean algebra or Boolean conditions to control the flow of execution is with what is generally called an if-then statement. That is, if something is the case, if something's true, then we take action. Java doesn't use the keyword then, but these are still generically called if-then statements. So you can see in the syntax in Java, the basic syntax is the keyword if, lowercase I, and then a Boolean condition in parentheses, and then some Java code. So this is not actual Java. Do this won't actually do anything. It's just meant to be a pseudocode that you can look at and compare the syntax of a correct Boolean, Java Boolean statement with the flowchart and also with other languages that you might be used to. The idea you can see maybe more clearly in the flowchart is if the condition is true, then that code inside the curly braces is executed. If it's false, it's skipped, it's bypassed. So the if-then statement branches the flow of execution into two branches. And depending on how you've written the Boolean test and what data is entered into it when it runs, the flow of execution goes one way or the other. It can't go both ways, and it can't go neither way. It will go one of those two ways. Again, the outcome of the conditional test is either a true or false. It can't be both, and it can't be neither. I should mention a little bit about the curly braces because I've got two examples here. The first one doesn't have the curly braces and the second one does, but if you look closely, I explain it, in the table header. It says use braces to surround multiple statements. So in Java, frequently we want to do a lot inside of these if statements. It isn't enough just to do one quick thing. So if you have to do more than one thing, you have to surround all of those statements with the curly braces. The shortcut kind of is that if you're only doing one thing, you don't need the curly braces. You can just use the syntax on the top, if condition do this. The problem I see a lot is that you start out thinking, I'm only going to do one thing. This is a simple program. I don't need the curly braces, and my pinky's tired, and I don't want to type them, so I'm going to leave them off. But then you come back later and add some more steps, some more statements. And I've seen code turned in like this. Actually, it looks a lot like the lower example. It says if condition do this and this and this, etc. All of the statements are indented over to the right, so you glance at it and it looks like, okay, that looks right, but they haven't added the curly braces. And then the code doesn't work right, and it's not a compiler error because if you leave off the curly braces, say in that lower syntax example, it's valid Java code. All it's saying is if condition do this, that's the if statement. And then after that, it will always do the remaining statements because they're not associated with the if statement if you leave off the curly braces. So it's just good, at least initially programming, if you just always use the curly braces. That way, if you come back and need to add additional statements to an if statement, you won't have to remember, oh yes, I also need to change the structure by adding braces. We can make this more complex. There is an else condition in the if-else statements. So if you wanted to execute code for a false condition, you can also specify code in a section of the if statement to be executed in that case. So it's, in concept, it's pretty much the same thing. It splits the flow of execution two ways. The true way, just as in the prior example, executes if the condition's true. But in the if-else statement, now you're able to add code that will execute on the other branch. I mean, this is one of these things where you'll think through what is it I'm trying to achieve, and do I have code that I need to execute if this condition's false? And then if so, the if-else is the variation that you want to use. You can also essentially create more complex logic a couple different ways. One is by using this if-else if variation. That is, you can do more than one if test that will be evaluated top to bottom. The first condition it hits that is true, that will be the code block that gets executed. So just looking at this example, it says if condition A, then there's code A, else if condition B, then there's code for B. So looking at the flow chart, again, this is where flow of execution is. You're going to start at the top, and it's almost something that you can put your finger on start and then trace your way through it as you think through the logic. So if condition A is tested first, if it's false, then that code A will never get executed. It doesn't guarantee that the code B will be executed. It just guarantees at that stage that the code A will be skipped. If condition B is false, you can see here, the code B is also skipped. So this simple if-else if statement has the possibility that either code A or code B will be executed, or neither if both of the conditions are false. But you could keep adding on to this. You could add another else if and another else if you wanted to. And you could end it at the very bottom with an else that would give you the opportunity to provide code to execute in the case that all of the conditions were false. So each of these examples I've given you the generic syntax for, and you can keep adding on to them and adding on to them and adding on to them if you want. If your program has need for logic that is more sophisticated, that's one of the ways that you get to it. All right. As a first example, we've actually written apps with multiple widgets in them. We've had an app that had a button and a text field and a slider. The thing about those examples that were based on those three widgets is each of the widgets uses a different listener. The button uses action listener. The text field could use action listener, but we weren't hooking it up to the listener. We were using it to output data, not input data. And then the slider used change listener. So there was no possible confusion about when the user pressed the button, for example, did they press the button or did they move the slider? There's no possible confusion because it's two different listeners and two different event handlers. That there was no real opportunity for your code to get confused or to be confused writing the code. That changes a little bit when we have multiple widgets that use the same listener. So as just a simple fictional example, I've got this low-level formatter beta, and the idea is this is some sort of a disk formatter that wipes your disk. It says, do you really want to reformat your hard disk? And there's two buttons. Yes, I've backed everything up, and no, I've made a horrible mistake. The thing is, if we hook both of those buttons up to the action listener, and we have one single action performed method, we're going to need something in that action performed method to let us know which button the user pressed, right? Because it's important. If they pressed no, then we don't want to reformat their hard drive. If they pressed yes, then we can go ahead and do it, but we need to know which button they pressed. And if we're in a single method, a single action perform method, we need the syntax to do this. Obviously, one way to do it is to use an if statement. There's only two buttons, so you could get away with an if-else statement. I've done a little bit more here, which is I've written it as an if-else statement to give you an example of that. There's no real benefit here unless if the program did get more sophisticated and you hooked more things up to the action listener, you might want to know that or see that as the developer at the console that says, hey, wait a minute, you have an action event that was created that you're not handling. That's the only thing that this little added bit of complexity does. So here's the way you write the statements. You can ask the action event. Remember, it's an object, so it has built-in attributes and methods. You can ask what the source of the action event was. You can say which button was pressed, essentially. And the syntax is pretty straightforward. It's e.getSource, so there's a method in the action event called getSource. It returns the source of the event, and then if my two buttons were named yes button and no button, those are two J buttons, I can literally just write it this simply. I can say if e.getSource double equals yes button, then I'm gonna go ahead and do the format. And so there's a fictional method there I called doFormat. If it's the no button, so I say else, if e.getSource double equals no button, then we're going to quit or do something else, but we're not going to format. So system exit 0 is just a line of code that will quit your app. And then again, the final else is just saying it wasn't the yes button and it wasn't the no button. So at some point, you must have hooked up something else to the action listener, and you need to probably deal with those action events. Again, this is a fictional app. I do not actually have in the download a version of the low-level formatter that will format your hard drive. That would seem to be maybe a liability issue. I don't know, but please don't think I've included anything like that in the download. I should back up just and say if you have been working with event handling programs and have been using the alternate syntax that I showed you in class, you can avoid this need because you can, in fact, use separate event handlers for each button, in which case you wouldn't need to do an if-else kind of check, because if the button has one and only one event handler, the only way you can get to that event handler is if that particular button was pressed. But that's not always the way you want to program it. And if you have a unified event handler like this action perform, then you do need to parse through the action event object and figure out which of the buttons was pressed. All right. So using and, or, and not. So you can use these in a Boolean expression to add a little bit of sophistication to the expression. And or allow you to connect two Boolean values or Boolean conditions and evaluate them together. So the and statement, I think this is probably review, but let me just be really explicit. The and statement will take the two conditions you're merging and result in a true if and only if both A and B are true. So for an and to be true, both conditions have to be true, the one on the left and the one on the right, whatever they are. For an or to be true, either one of them can be true. So for or, could be condition A is true, or it's also okay if condition B is true, but one of them has to be true. And then again, the not simply flips the result from false to true or true to false, depending on what you're writing. And it may seem like a weird thing to do, but it kind of goes back to as programmers, when we're writing these conditions, we'd like them to be written in such a way that you can really read them, even read them out loud, and they make sense. For example, in the overview chapter, I used a not to say something along the lines of if not timer done. We had a fictional timer variable that was running, and timer done was a Boolean that would go to true when the minutes hit 90, I believe, was how the example code was written, because the recipe called for 90 minutes of boiling. So we used the not to be able to write the line in such a way that if you read it out, it made sense even in English. You could say, if not timer done, do this and this and this. Well, that you can read that and make sense of it, and those are always the best kind of Boolean conditions, is ones that do make sense, as much sense as possible, just in terms of using ands and ors and nots, and also naming your Boolean variables something that makes sense. But the other thing I don't think I mentioned is there are always ways to write the same Boolean logic or Boolean logic that will get an equivalent result differently. So to some extent, everybody also develops their own style of naming variables and writing these sorts of conditions. And one way is not necessarily right or wrong. There might be a more elegant, a more parsimonious, a clearer way to write something, but you can frequently write the same exact Boolean condition several different ways. All right. So there are some common mistakes that I see, and that I'm sure I've made more than once. Certainly, if you've watched me coding live on any of these days, you'll know that typos are a frequent companion. So one of the things people forget the need for the outer parentheses, and it happens. Well, it happens for a variety of reasons. For instance, if you're coming from the mobile class, Lua did not require outer parentheses. So if you've gotten used to that syntax, then the outer parentheses are something that you'll have to make an extra effort to remember. When I type these if statements in code that I'm typing, especially if I'm coding live and talking to you as I'm coding it, I always type the keyword if, and then I type the parentheses and leave them empty, and I type the open curly brace and hit return in Eclipse so I get the pair of curly braces. Then I back up and start thinking about the condition and what I want to put in the condition. But I always try to start out with an empty if statement with all the correct parentheses and braces. And then if I need to add more as part of fleshing out the logic, that's fine, but I have the required set from the very beginning. So the comparison here also is this top one. It is a little bit confusing to the eye, and this is probably the case where I see it the most, because if you look at that first line of code, it says if open parenthesis x greater than 10 close parentheses and open parentheses x less than 100 close parentheses. If you just look at it, it's the line that says bad. The comment is bad. It appears that it does have an outer set of parentheses. So at least at initial glance, it doesn't look obviously wrong to a lot of people. But what you need to know that's going on is Java's taking those outer parentheses and using them to mean what is inside of them is a complete and valid Boolean comparison. And if you take those outer parentheses away on the bad line, what's left is not a valid statement. It does not have matching sets of parentheses for everything. So you always need the outer parentheses no matter what you're doing inside of the parentheses. You still need those outer parentheses. And then the other thing people try to do sometimes, and this may work in some languages, but it's not super common, but if you wanted to do a comparison like at the bottom where the comment says also bad, it says if, open parentheses, 10 less than x less than 100, close parentheses. That is the way you would frequently write it, say, in a math class. And you might even write it this way in your own notes about the logic in your program to mean x has to be between 10 and 100. Unfortunately, Java just doesn't parse that sort of Boolean expression. Those are two Boolean tests. If you want them both to be true, then you have to write them as two separate tests and AND them together. Or in other words, the line of code directly above is what you would want to do. You have two tests, x has to be greater than 10 and x has to be less than 100. That's the line that's good. Both of the other lines are examples of code that will not compile correctly, let alone run. All right, so far we've focused entirely on numbers, but Boolean logic is is for any type of data. We do frequently have a situation where we want to know, did the user type something? For instance, we might prompt them for a passcode, and they'll type in their passcode in a text field or in an input dialog, and then we need to check it. We need to say, is that code one of these valid codes? Does it match their password? Does it match the manager's code? Does it match a coupon that's valid? That's really common. In addition, we'll have interface elements like the JComboBox that when the user makes a selection from that, what we can pull out of that selection is the text that was selected. So I've got an example that's coming up, which is uses the menu for this fictional pirate pizza restaurant. One of our menu items is the pirate pepperoni pizza. And so we might want to know, did the user choose that? Was that what they selected from the UI? So here's where things just get, there's a little twist here that maybe you saw coming. I hope you saw coming, but maybe you didn't. So the thing is, you might recall, strings are not primitive data types. They are class-based data types based on a class called string, capital S, string. Because of that, we cannot use the basic Boolean comparison operators in general. The correct way to test if a string equals something else is to use a method that's built into the string called equals. So the syntax would be, in this case, if the user made a selection from some UI element and the result had been stored in a variable called names, strings I've called it here, name $, you don't want to test it by saying, does name string double equals pirate pepperoni pizza to take action if it does. Instead, you want to write it like the lower syntax, which is if namestring dot equals, and then in parentheses pass it pirate pepperoni pizza. That will do the comparison of the text value of both of the string objects. And it's something so many people forget and leave off or do it the wrong way. And at least in past versions of Java, it's not a compiler error to use the double equals. It's just testing something slightly different than you think it is. It's comparing the two objects to see if they're essentially the same object under the hood, stored in the same memory location under the hood, if you will. And if they are, it returns a true, but it doesn't technically check that the text values are identical. So there are ways in which the above example will not work correctly, and the lower example is the one that will run correctly. I will try to make a big deal of that anytime I write code that involves testing a string value against another string value, just so that maybe via repetition, this will become familiar to you. There is an alternate syntax that you could write instead of if-then statements. And this is more of maybe an advanced usage note. Anything that you can do using the Java switch block or case block, you can do with if statements. And so if you've gotten used to if statements, or you find yourself looking at the if and else if statements and thinking, yes, that makes sense, that's I can write stuff like that, or I have written stuff like that, or I've already gotten into the homework for the chapter and I'm not having trouble with it, then the switch is an alternative that you can ignore. There are no cases in which the logic that you need to enact in your program will require a switch statement, because you cannot do it with if statements. That will not happen. However, the switch block, and technically it's called the switch statement in Java. In other languages, it's referred to as the switch block or a case block, is a way to write logic in a more compact form that in some cases, what you get used to, it is easier to scan through and read and to make sure that maybe you're doing the right thing. It does not handle as complex situations as if and else if statements will. It is designed to compare a single integer value. For instance, something you might get by asking, what is the index number of the selection that the user made from some UI element? You'll get an integer. If they selected the first option, it'll be integer 0, index number 0, and so on. In that case, you could write a switch block fairly compactly to run through the various possible index numbers and then supply code that will run as appropriate. It gets a little bit more complex in that by default in the switch block, the flow of execution starts at the top and flows down to the bottom, but it keeps flowing. If you want the flow of execution to stop, for instance, you can see in this example it says case A, and then there's a comment that says some code here for A, and then there's a keyword break that we haven't seen before. So break says, okay, you're done. If it was A, you're done. If it's not A, then it will skip that break and evaluate B. If it is B, it would execute code beneath B, but you'll notice I've essentially combined B and C together. So in a switch block, you can stack cases like this so that the same code is executed for both B and C. And then I've got a break after there. If I didn't have a break, it would keep going down. There is also a final optional default case in which you can put code that will execute if none of the cases are true. Sort of like that final else in the if-else-if block we talked about earlier. So here's actually an example. Let me run this app and then we'll talk about this. So I'm going to switch back to screen sharing. Do you guys see Eclipse?
Yes.
Perfect.
Yeah.
Okay, so this is an example that's in chapter 7, which we skipped. So I'm going to add a new project for chapter 7. I'm going to try to add a new project for chapter 7. I'm going to call it, you might not have seen this coming, but I'm going to call it chapter 7. I'm going to skip the module, do not create. I'm going to open up my downloads, which is where I've got the J4B resources file, which I've actually downloaded a couple times in class, and so I have different versions of, but I'm going to hop into chapter 7 strings, and this is StringComparePlayground. And I'm just dragging it over to chapter 7. I'm going to pause. I was hoping it would open up. It's not opening up. So I dropped it in there, but it didn't put it in the default package, so I'm going to move it into the source folder, at which point Eclipse will then create the default package and put my app in there. So what this app does is, part of chapter 7 is a discussion of how do you compare two string values. So it goes into a lot of detail on what we just talked about fairly briefly. There are different ways to compare two string values. So here's our menu. Here's the menu for our fictional pirate pizza restaurant. We've got pizza margherita, pizza pirate pepperoni pizza, Fargo Northern cheese pizza, Italian garlic pizza, Key Largo parrot pizza, and Argentine grilled steak pizza. And you'll notice maybe that the names are extra pirate. Some of them are extra piratey because I've used ARRG in the menu item name. And so there are questions in chapter 7 which ask you to figure out how piratey a particular name is by searching for ARRG in it and determining how far into the name you find ARRG. That will drive the piratiness of the name. So just looking at the names, you can probably figure out that the last one, Argentine grilled steak pizza, is the most piratey because it starts with ARRG. Pirate pepperoni pizza is the least because it doesn't have an ARG in it, but then it does have the word pirate, so it's not a complete loser. Anyway, that's the kind of stuff we do in chapter 7. So what the app does, it's a playground app, so it uses interface elements that we have not talked about, that we haven't studied. It's got 2 combo boxes. These are referred to as combo, it's actually got 3 combo boxes, sorry. It's got 2 combo boxes on to the left and the right of a center combo box. The thing about combo boxes is they can take one of 2 forms. One is they're just simple menus. Like the center one is just a simple pop-up menu. When you press it, you pick the comparison that you want to make. There are 4 key comparisons in strings. There's equals, ignore case, and then compare to and compare to ignore case. We just talked about equals. I'm guessing without any explanation, you probably could infer what equals ignore case does. It will do the same exact test, but ignore the case of the letters that are being compared. You might not have thought about that, but that should also, make more concrete to you that equals is case sensitive. Equals will look at the case of the 2 strings that you're comparing. So you do need to know that. And if you really don't care about case, the old way was we would always make the case all lowercase or all uppercase and then do the equals test. But as an even quicker way to do it, we can just say equals ignore case and then not worry about the case at all. And then to the left and the right of that center combo box are editable JCombo boxes. So you can see they've got the same basic widget, they've got the same basic pop-up menu, except I can make changes. I can propose a variation to any of these names. If I don't like Pirate Pepperoni Pizza and I want to change it to something with an arg in it, I could do that here or over here. And then I can do whatever test I've selected. If I hit the compare strings button, I will get the result that you would get in Java if you did that line of code, Pirate Pepperoni Pizza dot equals pizza margarita. It's false. They are not equal. They're not close to equal. If it's true, sorry, if I pick Pirate Pepperoni Pizza for both of these and redo the test, I'll get the true. If I edit it to change the case, let's change the P to a lowercase, and I do the same test, you'll see it's false now because the case makes a difference. I can switch it to equals ignore case, recompare, and get the true. Compare to does a kind of a similar comparison, except it scores the comparison. It gives you an integer number that scores how close the two words are alphabetically. If they are identical, it will give you a 0, which means completely 100% identical. And then the higher the number you get, the less close they are alphabetically. So the code I'm showing you in the outline is explaining how do we figure out which of these 4 tests the user picks. Because it's important, right? The answer that we get is driven by which one of these selections we make. If we say dot equals, we get a false. If we say equals ignore case, we get a true. If I say compare to, I get a number, 32 in this case. If I say compare to ignore case, I get a different number, 0. It's 0 because if I ignore the case, they're identical. So it is crucial for us to know the selection the user makes here. Obviously, it's also essential that we know these selections so that we feed the correct text into the comparison. But the difference is for the left and the right drop-down or editable combo boxes, I want that actual string because they could have edited it. So I want to read the text out of here as if this were a text field, and I want to read the text out of here again as if it was a text field that they could have edited. And then I want to do the correct of these 4 comparisons, I want to do the correct one. If you peek in the code for the playground, you'll notice when I get these values from the left and the right combo box, that's what I'm doing is I'm pulling the text out of them. But for the center one, I'm just pulling the index number that was picked. So equals is 0, equals ignore case is index 1, compared to is index 2, compared to ignore case is index 3. So in this app, I use both if statements, if logic, and also use a switch statement so that you have an example of a switch statement as well. All right, so now having seen this in action, the comparator box is the name of the center JCombo box. The left and the right editable combo boxes are read before we get here, and whatever the user typed in is stored in either S1 string or S2 string, S1 string being the left one and S2 string being the right one. So that's already done. That code is not complex. It's above it if you want to peek in the example and see the specific syntax, but what I wanted to show you here was the switch block so that you had an actual real example of a switch block, sort of to determine if this is syntax that you'd even want to put the effort in. You could write this exact same thing with if-then logic. But to use the switch statement, I need an integer as an input, so I get the selected index number from comparator box. The comparator box is the center JCombo box, so it either is going to be one of those 4 numbers we just talked about, 0, 1, 2, or 3. And I, as the programmer, I have to know what those mean. I need to know that 0 is associated with the equals method, a selection of the equals method. I have to know that 1 is a selection of the equals ignore case method, and so on. If I don't know that, I can't use this approach. Luckily, I do know it because I wrote the program, and even if I had forgotten, I could glance up and see what the 4 different items were in the list and what order they were in. But I happen to know that 0, 1, 2, and 3 have these meanings. So it makes the syntax pretty compact. I can say for case 0, then I'm going to do the equals test. I'm going to set the text on the result text field to the result of s1 string dot equals s2 strings. And for a case 1, 2, or 3, I'm going to do the same exact thing but using the different built-in method, equals ignore case, compared to, or compared to ignore case. I break after each case because I'm only doing one test. It doesn't make sense to stack any tests together. And I provide a default that will never execute, but I do this because occasionally you'll write code like this and then you'll realize, oh, I needed another option. I'm going to add another item to the list, but then you forget to update your switch block. And then you can't figure out why when you select the fifth or the fourth or the fifth list item that your code isn't working correctly. So putting something in here like result text field.setText, or system.printlning, you've made a selection that isn't handled, something like that as the programmer so that you see it really obviously and know where to go back and fix your code is sometimes helpful. The other thing I've done, which I don't want to just talk over and move on, is I've converted the results of these tests to string data. SetText requires string data, but s1 string dot equals s2 string returns Boolean data. The result of that equals test is either a true or a false. That's not text. I have to convert it to text. I could use boolean.toString to do that, but the other way to do it even more quickly is just to concatenate that result onto a string. Anything that you concatenate onto a string, Java converts to a string. It makes it work to form a new string. And I have done this in one of the apps, one of the demo apps, but I used a little bit of string. Well, I did it when we were playing with the mouse and clicking the mouse, and I said, the mouse is located at location x equals, and then I added on e.getX, and then I added on a comma, and I used string concatenation to form that, but you might not have realized that e.getX returns an integer number. An integer is not a string, and I didn't have to convert it. I didn't have to convert it because I started with a little bit of string that said the location is, or something along those lines. Mouse clicked at. So string concatenation made that work, and I'm using the same trick here, except I don't want to have a string at the beginning, so I have an empty string. Those little double quotes that you see that may look kind of weird to you are just empty strings. So I'm using an empty string and concatenating something else to it that's not a string, and Java makes that work by making the result of the concatenation a string. And you might say, well, but it's an empty string, that's cheating. You can't do that. Cheating or not, I don't know. It's not cheating. It actually does work. It's a really common way to do this, and it's to some extent it's easier to read than having boolean.toString and extra parentheses in there. Although that's not hard to read either, but this I could easily fit in single lines in the keynote slide without having to wrap. And so sometimes I make the coding choices literally based on what I can show in Keynote and keep on a single line. All right. We'll talk in more detail about JComboBoxes later and using them. They are obviously a super handy widget. You can store a list of options in them, but like in lots of cases in Java, they are also really powerful. You don't have to put text in them. You can put anything, almost anything in them. You can put images, you can put buttons, you can put panels, you can create anything you want and put it in there. But because of that, then the syntax for using them is a little bit more involved than something like a simple button, or a simple slider. But anyway, we'll jump into that in more detail in future examples. I want to stop here on activity 1. This is a great breaking spot, and we're almost out of time. So we'll pick up here next time, but I'd love it if you would dive in and try this. It's totally doable. It's just a quick app with 2 buttons and I'm actually using a label there. You see the 7. Since you don't see the text field around it, it's not a text field. I've just used a JLabel. So if you want to play around with using JLabels, those are also explained, I think, in chapter 7, but there's a class called JLabel, and you create a new JLabel using the syntax JLabel, L equals new JLabel, and then you put whatever text in it you want. I used it in the StringComparePlayground to display the title string compare playground. And also, if you notice next to the result text field, there was the word result. That was also a JLabel called result label that had the word result in it. Anyway, you could use the JLabel if you want to master that, or use the text field as the output. That's fine too. But the idea is when you hit the count button, I want it to count up. But when you hit reset, I want it to go back to 0, and I don't want the count to go past 20. So even if you hit the count button again at 20, it should never go to 21. So this will require a little bit of if-then logic to make it work. But I hope you're comfortable with the if-then logic. I have a second poll just to ask you about this idea of flow of control to finish this out. So you've now learned almost the entirety of the basics of flow of control. The one thing that we've left is repetition, and repetition is a topic which is a little bit more confusing to most students than a simple if-then kind of structure, but totally understandable. So I'm very encouraged by the results. So far, you guys are saying you generally understand it, but you do get tripped up a bit. And honestly, that's probably how I would have to answer. Occasionally, I will type something in too quickly, not thinking carefully enough, and then wonder why on earth it's not running. Or obviously, a student shows me their code, and I look at it, and it looks fine, to me sometimes, and I don't see the issue. I don't see a typo. I don't see a misspelling. I don't see a data type mismatch issue, and yet the code is not working. Sometimes it ends up being a flow of control issue that I've looked right over. I might ask this exact same poll after we cover repetition. That concludes the coverage of the material today. I did want to say, again, I said this at the beginning, but it is possible that I'll be spacing this chapter out to 3 days instead of 2. If so, and that's probably what I'm going to do. If so, that'll push the homework check and the lab day 2 past the next weekend, which would give you an extra weekend time to try to get caught up. I think that might be the more valuable way to do it, but I'm also going to poll you guys today after I get this video up there tomorrow and just ask you how the course pace is going and how you guys are keeping up with the material. But I'm done. I'll hang around for any questions and answers if you guys have any questions or answers.
Hi, Dr. Carlson.
Hello.
I'm right here.
Hi, Ray.
I'm just wondering, just for the chapter 7, did
Yes.
you just skip it, or
I did.
It's
a long chapter. It's a 2-day chapter for sure, and we haven't ended up with 2 extra days for it. And in terms of prioritization, it's much more important to me to get to the business calculations chapter, the working with money chapter. As a business programmer, I think that's crucial. And working with strings is something that you can pick up. And like I said, string concatenation and using dot equals are probably 90% of what we do with strings. So formatting stuff to look like money will be the other thing, and I will cover that in chapter 15. So you'll get the key features out of chapter 7 just as we cover material in other chapters. More than likely, I will delay the homework check to the 13th and then push the exam to the 15th to hand it out.
Okay.
But that gives you guys it gives people another weekend to try to get caught up if they're behind before I hand out this first exam, which is what I want.
How's the exam look like? I have no idea.
It's a take-home exam, and I normally ask for 2 programs or 3 programs. And I give you screenshots of an idea of what they should look like, and I tell you in detail how they should work, and then you just get to code them. It's open book. You use Eclipse. It's much better in terms of figuring out if you know stuff or can do stuff than a multiple choice test would be. So that's why I do the take homes.